So now we have an equal sign in this. So x over 3 minus 1 over 4 equals 12. 1 over 12. Now the easiest way to solve these problems is to find the least common denominator of every denominator and then multiply both sides of your equation by that. So the least common denominator is pretty easy to see is 12, right? And then you multiply 12 times both sides. Now, in mathematics, an equation, you get an equivalent equation if you do this. You multiply both sides of the equation by the same number, divide both sides of the equation by the same number, add both sides of the equation by the same number, subtract, take the square root of both sides of the equation, square both sides of the equations, as long as you do it to everything on both sides. It's equivalent. What does an equivalent equation mean? It means that an equivalent equation includes all solutions to the original equation. Now, what we'll find out is when you square both sides of an equation, you can get extra solutions called extraneous solutions. That's coming. And when you do that, then you have to check your solutions to make sure they're solutions to the original problem. But we don't have to do that now. We're just going to be multiplying both sides of the equation by the same number. And in this case, it's the least common denominator. So then this becomes, as we distribute the 12 on the left-hand side, and then when we, on the right-hand side, notice it's just a term times a term, and the 12s cancel, and we just have 1. Now on the left-hand side, the 12 over 3 gives you 4, and on this one gives you 3. So now then 4x minus 3 equals 1. And then from there, it's just solving it like we always do. Move the 3 over, we get 4x equals 4, divide by 4, x equals 1. So this is the solution to the problem. If I were to put 1 in for x on the original problem, it would make a true statement. Now, what you should be able to do, and I think pretty readily, you should be able to basically go down to here. Once you multiply this and then do the distribution, you should be able to kind of get down there. So 6. So this is 3x plus 4 over 12 minus 1/3 equals 5x plus 2 over 12 minus 1/2. So what is the least common denominator? 12. So we bracket this, multiply it by 12, bracket this side, multiply that by 12. Now we distribute the 12. And we take 12 times this first term right here. Notice the 12s go out. What do we have left? 3x plus 4. Everyone, right? I'm just doing it. And then you do this 12 times this minus 1/3. So that's going to be 1, what? Minus 4? The 3 into the 12. Is that right, Aaron? Okay. Now on this side, this 12 times this term right here, 12s go out and I have what? 5x plus 2. And then the 12 times the 1/2 minus 6, right? Is there any part of this you're not following what I'm doing? I'm just going in this, I'm just making this step right here, right? In this particular problem. Now then, you combine terms, so the left-hand side is 3x, the right-hand side is 5x minus 4. Then you're going to go right with your variables and left with your constants. So this is 4 equals 2x, and x is going to equal 2. And that means that if you put 2 into for x in the original equation, you'll come up with a true statement. Any questions on that? Okay, we'll do 10. It says 6 over 4 minus 3x equals 3. What's the least common denominator?
12.
4 minus 3x, right? Now notice this straight line right here actually does this. There's an imaginary bracket around this, correct? That straight line is a bracket. So then I have to multiply 4 minus 3x on this side. So on the left-hand side, what happens? Those bracketed items are the same, and they cancel. They're multiplicative inverses. So the left-hand side is 6. On the right-hand side, we have to distribute the 3 across this. So it's going to be 12 minus 9x. Now we'll go left with the variables and right with the constants. So we get a positive numerical coefficient. It's plus 9x equals 6. Divide by 9. Reduce that down 2/3. And there's your answer. Any questions? Okay. $14. 3 minus 12 over x equals 7. What's the least common denominator? X. Multiply x by both sides. On the left-hand side, what do we have? 3x minus 12, is that right? Equals 7x. So we take the 3x over to the right-hand side, minus 12 equals 4x, and x is going to equal minus 3, right? Okay. That's the number that makes the original statement true. 18. It says 5 over x plus 3 equals 3 over x minus 1. What's the least common denominator? Is it x plus 3 times x minus 1? Is that right? So we multiply both sides by x plus 3, x minus 1. Now remember that that line brackets this, and this line brackets this. So on the left-hand side, what are multiplicative inverses? X plus 3's, right? On the right-hand side, what are multiplicative inverses? X minus 1. So what we have left is x minus 1 times 5. And on the right, we have x plus 3 times 3. Then you have to distribute the left, 5x minus 5 equals 3x plus 9. Move the variables left, 2x, constants right, 14, x has to equal 7.
Hold on a second.
Say that what?
Hold on just a second.
Now, this particular problem, I'm going to write it here. You could do it by what we call cross multiplication. 5x plus 3 equals 3 times x over x minus 1. What it is you multiply the means together, that's these two, and you multiply these two together. So you have 5 times x minus 1 equals x plus 3 times 3. Now, notice, what is that? Just exactly like that right there. Cross multiplication. And then from there, it just goes on to be the answer just like on that previous one. So you got in your arsenal of things to attack problems, you got, if the case is right, you can cross multiply. You can always multiply both sides by least common denominator. I'm going to say that again. You can always multiply both sides of the equation by the least common denominator. If the case is right, you can cross multiply. Okay, this one, notice that what it is, the reason you can cross multiply is that this is a term and this is a term because that straight line brackets it. And you have a term divided by a term and a term over there. Now, if that don't happen, you cannot cross multiply. Now, if you look 18, if you look at 15 right above it, you cannot cross multiply. You see, you do not have a term over a term. So could you cross multiply on 12? Someone said no. That's right. Could you cross multiply on 21? Yeah, because that's a bracketed term over a term, right? So could you cross multiply on 24? No. Do you see the difference? Do you see what you can and cannot do it? Make sure, can you identify? How many could identify? Which one you can cross multiply and which one you cannot? How many cannot identify? You know what I'm saying? Everybody knows how.
I like the other one more.
Yeah, the multiply by common factor is actually the safer method because you can always do that and it's always right. Cross multiplication, if you misidentify, you make a mistake. So let's look at 24. says 2x over x plus 2 minus 5 equals 7x over x plus 2. So can we cross multiply? No. We have to multiply by the common denominator. So we're going to multiply both sides. And what is the common denominator?
X plus 2.
X plus 2. So now then we distribute this x plus 2 times this thing. And what do we get?
2x.
2x, right? Then we go x plus 2 times minus 5. Now, if you can do it, you could go minus 5x minus 10. If you're afraid of losing signs, then what you better do is you better do this 2x and go minus 5 times x plus 2. Because it's real easy to lose that sign as a negative in front of that 10. And that'll make your answer wrong. Whatever. Oh, and I forgot to put this x plus 2 over here because we're multiplying both sides by the same number. So this equals then what? 7x. How much? Now we have to get the variables on one side. What are we going to do? Go right with the variables? We have 2x minus 5x is the minus 3x on that side. We take it over to the other side and we get what? 10x. And then we have our constant minus 10. Divide by 10, we get x is equal to minus 1. And there's our answer. Okay. The problems change a little bit, 31, 32, and 33. And what I'm going to do is I'm going to do your problem 33 for you. Eight over 1 equals 2y plus 2 plus 1. Can you cross multiply? So what are you going to multiply both sides by? Y times y plus 2, isn't it?
It's fine.
Is that this a y minus over here?
Yeah.
Okay. All right. On the left-hand side, what do we got? Eight times y minus 2, right? Now we have to distribute, right? So what's the first term? 2y? Is that right? Then it's plus what? Y times y minus 2. Correct? Now if we distribute on the left, it's 8y minus 16 equals 2y plus y squared minus 2y, right? Now we have a second degree term, so what does our algorithm say we do? combine like terms and write it in descending order, right? Gets 0 by itself. So if I wanted the leading numerical coefficient to be positive, where would I go with the 0, left or right? 0 on the left, 0 on the right. On the left, right? So I'd want to go 0 and I'd want to take everything else to the right. And then I'm going to write it in descending order. So the highest degree term is y squared. Now I have an 8y over here, a 2y and a negative 2y. Those two y's go away, right? This 8y comes over as a negative 8y. And now we have a 16 that comes over as a positive. So now we have 0 by itself, trinomial written descending order, leading term positive. No common factor is the trinomial special case. Well, the first term is a squared term, isn't it? What's being squared?
1.
Is the trailing term a squared term? 4, isn't it? Isn't 4 squared 16? 4 is being squared. Now, the middle one, is it 2 times the first term times the trailing term? Yeah, that's a special case. That factors, because this is negative, factors into y minus 4, the quantity squared. Right? Now, the principle says that what do? Y minus 4 equals 0, right? So y has to equal 4. Okay. "31 is going to be a similar problem, I believe. 32 is too. Okay. Number 34 says a ratio and a proportion. No, not proportion. A rate. Know what the difference is? Anyone know the difference? Both of them are comparing one number to another. But the difference between a ratio and a ratio, the units on the numerator and the denominator will be the same. So it could be 7 inches to 10 inches, it could be 7 feet to 10 feet, 7 meters to 10 meters, 7 seconds to 10 seconds. It's the units are the same. A rate, the units are different. We had 7 miles in 10 hours. That's a rate, right? 7 miles. That's my rate when I run the marathon. Must be a joke. Okay. So that's a rate, the units will be different. So that's a difference between them. They're always comparing one number to another. Now, the 35 says a proportion. And proportion is when there's an equal sign. It would be if you were trying to do 7 inches is to 10 inches as X inches is to 20 inches. that'd be a proportion. That would be a ratio in proportion. You'd be trying to solve something. Now, what we're going to do is we're going to do things called similar triangles. And similar triangles are triangles in which the angles are all equal. And when the angles are equal in triangles, the sides are proportional. So in similar triangles, you can use this kind of thing. So if you were trying to find this triangle had one side that was 7, another side that was 10, and you knew the corresponding side was 20 in the other triangle, then you were looking for the side that was corresponding to this side and find out what it is. Well, what you can do, we'll use a common denominator of 20 because that's what Matt likes to do best. And that says that the other corresponding side is 14 inches, right? So the corresponding side to 7 is 14. And that makes sense. This side, and this side, this one's twice as big as this. So this side should be twice as big as that one, right? But we can solve it. We could cross multiply the thing too, right? We could solve it by cross multiplying by going 7 times 20 equals 10 times x, right? Okay. 36. X over 12 equals 3 over 4. Now all of these problems, if you notice, all these problems through 50 are all, you can solve them by cross multiplication, right? Can you solve them by multiplying by the least common denominator? Yeah, you can always solve by the least common denominator. But these all lend themselves to cross multiplication. Now, if you look at this, if you have your variable in the numerator, if you multiply both sides of the equation by the denominator on that side, always, whether or not it's the least common denominator, it'll solve your problem the quickest. Now that happens to be the least common denominator, but there's going to be instances. We could cross multiply this thing. We could multiply the means, 4x, times the extremes, 36, divide both sides by 4, and get 9. $40 is x plus 3 over 12 equals 5/6. Probably, in this case, it's still multiplying by 12 is the fastest way, isn't it? You could do cross multiplication, but the 12s go out. You got x plus 3 on this side. You got 2, 10, x equals 7, right? Now 44.
Can you hold on just a second?
Oh, sure.
Sorry. All right, thank you, sorry.
You bet. No, that's okay. I don't want to go too fast.
You're good.
So here's 2x, 2 over x equals 4 over x plus 1. Now, whatever we do, we're either going to have to cross multiply, and that would be if we multiply the means times the extremes. Or we'd have to multiply by the least common denominator. And if we did it this way, and I'll go up, we'd have 2 times x plus 1 equals 4x. No matter whether we did it that second way or whether we did cross multiplication, we're still going to end up with the same numbers. Right? And then we have to 2x plus 2 equals 4x. And then 2 equals 2x, and x is going to equal 1. So any question on that?
Wait, x equals what?
X equals 1. It's 2 over x minus 1 2x plus 1. And I'm going to cross multiply 2 times 2x plus 1 equals 6 times x minus 1, right? If we did multiply both sides by the least common denominator, you'd still get to the same point. 4x plus 2, 6x minus 6. Now we're going to want to go variables right, constants left. So we would have 8 would equal 2x, and then x would equal 4, right? Is there anything on that page that you need to look at? Yeah. Okay, similar triangles. Next set of problems. Now notice on similar triangles, a similar triangle is one in which the angles are all equal. And when the angles are all equal, then the sides are in proportion. So the sides are proportional. So if I look at 52, I'm trying to draw this thing. Breaks that line up. It's breaking those lines up on there. I don't know why. So what these are, this is A, C, B, this is D, E, E, F, I guess. Now they say this side is 5 inches. This side is 8 inches. Now, they're just assuming that you can see the sides that are proportional. This one is 8. Usually the side opposite a vertex is called small letter. So this is side B, this would be side A, and this would be side C. This would be side E, this would be side F, and this would be side D. Notice that E and B are proportional, D and A are proportional, and C and F are proportional. That's the way they're drawing. So they want to know that DE, they want to know this length here, which is F. They want to know F. And what you have is you have the side, they want to know F. And you have the side 8, E. This is what I'm going to do. F is to E as C is to B. That makes sense? That's the proportional size. So you don't know F, but you know E is 8. You know C is 8. And you know B is 5. So that's your ratio and proportion. And then you just solve for F. Well, this problem right here, don't multiply by least common denominators, don't cross multiply, but to get F by itself, what would you do? You'd multiply 8 times this and 8 times that. That's the easy way to do it. This cancels and you get F by itself. And you get 64 over 5. Now, if you wanted to, you could cross multiply. You'd have 5F equals 8 times 8, and then you'd have to divide by 5. And you'd have the same thing, right? That, to me, I'd like to go path of least resistance. And this one here is going to be 1, and it's 14 is 2, and 40 is 8. It's 12.8 inches. So that would be the use of that. And proportional sizes are used, just extensively in lots of different cases. Rates are actually used in medicine extensively because a doctor will order, for example, so many units of insulin, 5 units, and the insulin will be 1 unit in 1 cc or 1 unit in 2 cc's. Now then, how many cc's do you have to give? 1 unit to 2 cc's, 5 units, how many cc's do you give? We'd have to give 10. I mean, that would be excessive, but that's how it is. It's always, medicine is always given in so many milligrams per milliliter. And then you have to figure out those ratios and proportions. It's actually a rate and proportion. 54 says find the height. So what you have, triangle. Probably with a weird drawing, right? Something like that. And you have 9, 3, and 14. And this is what you're trying to figure out, that H. So what you can do is you can say H is to 14 as 3 is to 9. Right? And that would be, and what would, the easy way to do it is just multiply both sides by 14. If I got this right. H. Somehow that looks like it's wrong. No. So it's 42 over 9. What is that? 9 times 4 is 36, isn't it? And 6 ninths. So it's 4 and 2/3. And that's feet.